Today's lesson 58 is about symmetry. When looking at a two-dimensional figure like the triangle I have drawn, we can say that a two-dimensional figure has reflective symmetry or line symmetry if it can be divided in half so that the halves are mirror images of each other. Now I have drawn a red line here, and I can put it on our triangle. Our red line is our line of symmetry. We're going to call that line R. Line R divides my triangle into two exact halves of each other. If I were to shade this, now my pen here doesn't shade as very big, so it might take me a bit, but if I shade just what's on half of my line of symmetry R, I can see that it is the same shape and size as what's on the right side of line R. Okay, that's what a line of symmetry means. It has to be the same on both sides. If you put a line of symmetry in and it doesn't, for example, let's put another line of symmetry in here. Let's put line K in here. Now we get to look at line K. What's up top here and what's on the bottom is not the same shape, so line K would not be a line of symmetry. The only line of symmetry here in our triangle is line R. In the next slide, I will show you the three different lines of symmetry that a triangle, an equilateral triangle, can have. As you can see here, I have drawn three lines of symmetry. A regular triangle actually has three lines of symmetry. A regular triangle, remember, all of the angles are the same measure and the side lengths are the same measure. The red lines indicate our lines of symmetry. As you can see, it goes through each vertex, which creates the three lines of symmetry. Okay, example 1 says, draw a regular quadrilateral and show all lines of symmetry. Well, probably the easiest line of symmetry that you're used to seeing would be maybe like a regular window. And it actually creates two lines of symmetry. Here's the first. Draw my line and I move it in. There's my first line of symmetry. Now I can draw another. Not quite in the middle there. But you can see that I have two lines of symmetry and it starts to look like a window. However, there are a few more. There's actually two more lines of symmetry that we can use when we're talking about a regular quadrilateral. Here would be another. Going straight through the vertexes, or the vertices. There's one, and then the last one is just like that, except for it's going to go the other way. There. Now you can see that I have how many lines? I can label them for you. Let's call this 1, 2, 3, and 4. 4 lines of symmetry for a regular quadrilateral. Example 2 says, which of these figures has rotational symmetry? Rotational symmetry at the bottom here, you can see if a figure reappears in its original position more than once in a full turn. Well, we can easily look at all of these. Let's take a look first at the rectangle. If we rotate the rectangle once, 90 degrees, we do not have this shape we started with. If we rotate it again 90 degrees, we actually have the shape we started with. If we rotated it again, we do not have the same shape, and then the last rotation to get back where we started would be right here. And we have the exact same figure that we started with. So the rectangle has some rotational symmetry. Okay, let's look at the triangle. The triangle starts like this. Let's rotate it 90 degrees. Not the same. Let's rotate it again, 90 degrees. We have the original shape that we started with. Let's rotate it again. And again, we have the same shape we started with. So this triangle has 3 rotational symmetries. Let's take a look at the square. The square, if we rotate it 90 degrees, has rotational symmetry there. Let's rotate it another 90. Rotational symmetry there. Rotate it another 90. Rotational symmetry. And to get back where we started, has the same. So our square has all 4 rotational symmetries. Now let's look at the trapezoid. Now the trapezoid starts like this. If we rotate it 90, that's not the same shape we started with. Let's rotate it another 90. Not the same shape. It's upside down, so it's not the same. If we rotate it 90, not the same shape. So therefore, our trapezoid does not have rotational symmetry because it does not reappear in its original position in less than 1 full turn. So all 3 of them have rotational symmetry except the trapezoid. This concludes lesson 58. If you have any questions, please come see me before class time. Access would be a good time to come see me. Your assignment then is to do the practice problems on page 409, A through D. See you tomorrow.